This new section is entitled the Cauchy Euler Equation. They're always in the following form. Since it's a differential equation, you're going to have derivatives of y. You can have a y to the n, a y to the n minus 1, all the way down to y to the first, and then just y. Now, in each of these terms, you're going to have x to a power. And the power is always going to correspond to the number of times you're taking a derivative of y. That is, here you'd have x to the n, you'd have x to the n minus 1, x to the 1, which I'll just write as x, and x to the 0, which is 1, times y is just y. So I'll just write y. And of course, you can have some constants, multiples. You have a to the n plus a sub n minus 1, all the way down to a sub 1 plus a sub 0. And this can equal to some function. So just like we did in the previous section, let's call it g of x. That is what the Cauchy Euler equation will always look like. And if it doesn't, it can still be Cauchy Euler if we can get it to be like this. For example, if you have x, y double prime, let's see if this is going to work. Sure. Plus, boom, 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 plus y prime is equal to 0, or it equals to 8x2 plus 7. Now, if I were to this does not fit the Cauchy Euler equation like I have above. But if I were to multiply each and every term by x, everything is fine. Everything is fine. Okay? Now, you may say, well, what about the y term? Well, here the coefficient is 1, and again, coincidentally 1. Well, here, it's 0y. We're adding 0y. And if you prefer, we're adding 0 x to the 0y. Remember, the derivative of just y is the 0th derivative. So if we can get it to be in the form above, it's a Cauchy Euler equation, and the solution will be in the form of y is equal to x to the m. It will always be in that form. And our job is to find out m. Now, if you think about it, if you say you have 4x squared y double prime plus y say is equal to 0. If you let y equal x to the m, let's even stick in a y prime term. Not going to solve this problem, but going to show you something that I want you to see. 3x y prime plus 4. If y is x to the m, then y prime will be m times x to the m minus 1, and y double prime will be m, remember, just bring down the power, times m minus 1, and then make the new power 1 less. Now, if you multiply y prime by x squared, or 4x squared, when you multiply this by x squared, you're going to get x to the m back. You're going to get 4 times m minus 1. Well, let's actually write it out. You're going to get 4x squared times y double prime. M times m minus 1 times x to the m minus 2. plus 3x times y prime, which is mx to the n minus 1, plus, say, 4y plus 2. No plus 2. Plus 4y. Plus 4y. Remember, y was just x to the m. Now remember, when you're multiplying numbers, or terms, factors, 25 times 3 times 4 times 5. This is not a problem that you run to get your calculator for. Why? Because it takes too long to get your calculator. It's easier to say, that's 100, and that's 15. 15 times 100 is 1500. That is, the order you multiply is up to you. Of course, you might need a calculator. So you're going to go 25 times 3 is 75. That you should know. 75 times 4 might trouble you. You really should know that. It's 300. To be honest, 300 times 5 you should know. But it's much, much quicker to go. That's 100, and oh, that's 15. 1500. Why am I saying this? Because in the first term, we're going to do that. I'm going to multiply the x squared by the x to the n minus 2. And you add the powers. I choose to do this plus that instead of the other order. M minus 2. So you have some number m and you take away 2, but then you add the 2 back, you're going to get x to the m. When I multiply those 4 factors, ultimately I'm going to multiply x times x to the n minus 1. Well, this is just 1 less than m. When you add that 1 to it, you're going to get back m. And this term has an x to the n. That is why letting y equal x to the m works, because it's going to factor out. And then you're just going to get an equation that involves m's. That is, I know that I can factor an x to the m out. So when I factor it out from this term, I'm left with 4m n minus 1 plus 3 times m plus 4. And if this equals 0, well then I solve this quadratic equation. So let's actually do one. Suppose you have 4x squared y double prime plus y is equal to 0. So if y is x to the m, so this clearly fits the Cauchy Euler form, because since the derivative is 2, and the power of x is 2. Over here, it's understood that the derivative of y is the 0th derivative. So here I have x to the 0, which is 1. What's in the blue and the red in here is just y. It's just the red part. So it does fit like a glove. Fits the form of the Cauchy Euler. Okay, y prime will be mx to the n minus 1, and y double prime will be m times n minus 1 x to the n minus 2. So you have 4x squared times y prime, m n minus 1 x to the n minus 2 plus y, which is just x to the m. This is 0. Well, that product will be x to the n. So you can have 4 times m times n minus 1 x to the m's plus this. That is 1 x to the n. When you combine these, or if we distribute first, you have 4m squared minus 4 x to the m's. Sorry, minus 4m x to the m. What's in that bracket is how many x to the m's we have. And then we add one more. So that is how many x to the m's we have. Unless x is 0. Now if x is 0, then this equation just says y equals that. Y equals 0 is the answer. Okay, but if x is not 0, then this must be 0. Because if the product of this and that, and I don't care whether this and or that looks complicated or not, if you're multiplying this and that, and you're getting 0, either this is 0 or that is 0. One of the factors must be 0. Okay. We're going to equate 4m squared minus 4m plus 1 with 0. And now this is a quadratic equation. We solve it. That's A, that's B, and that's C for the quadratic equation. The m is negative b plus or minus the square root of b squared minus 4 times A times C. Well, this here is 16. And we take it away from 16, we're going to get 0. All divided by 2 times A. Now, I don't believe that one should multiply right away, because numbers get bigger. We have 4. Now, the square root of 0 is 0, and adding or subtracting 0 from 4 still leaves 4. And you divide this by 2 times 4. You should realize 4 goes into both of those numbers one time. So you get a half. Now, when you get a repeated root, that is, when the discriminant is equal to 0, you end up with a particular form. And that's what you as a student are going to have to remember. If you get one root, if m1 equals m2, the solution is going to be as follows. y general is going to equal to c1 x to the m1 plus c2 x to the m2 or m1 times ln of x. So in our case, m1 is a half. So y general is going to be c1 x to a half plus c2 x to a half times ln of x. And that is the answer to the first problem. Let's try some more, like always. Suppose you have x, y double prime minus 3y prime is equal to 0. Now this doesn't fit the Cauchy Euler equation because that derivative is the second, but the power of x is 1 less. 1's not important, but the fact that it's 1 isn't important. Could have been 0. But what is important is it's 1 less than what it should be. The power is 1. It's 1 less than it should be. And here we have y is a 1, and we have an understood x to the 0. If that power should be 1. It's 1 less. Since both of these powers of x's are 1 less, I can just multiply through by x. I'll multiply by x, of course, on both sides, and then I get x squared, y to the second, y double prime, minus 3xy prime. First derivative, power of x is 1. On the right side, it could have changed, but it didn't. It's still 0. Now, this is in Cauchy's form. Now, you should start realizing when it's just y, there's no number in front. When it's y prime, just one number. That number comes in front. And when it's y double prime, m, two numbers come in front. So is m and then one less. For the record, if you had y triple prime, three numbers come in front. M minus 1, that's the second number, so one more. M minus 2. If you had the fourth derivative, four numbers come in front. M, one less, keep going until you wrote down four numbers. 1, 2, 3, 4. X to the n minus 4. Now, if it is Cauchy, what you can do is ignore the x's. But if there was a number, write it. You'll see that in the next term. Ignore the x's and the y prime, y double prime. Since it's double prime, though, you're going to write down the first two numbers. The first number is always m. Minus 3 times this. Since it's Cauchy Euler, that is the power of x, and the prime matches, since it's just y prime, I write down one number, and it equals 0. So you have m squared minus m squared minus m, minus 3 more m's. So, if you take away 1m and you take away 3 more, you took away 4 m's. And if you were to factor this, you can factor out an m, say either that's 0, which happens when m is 0, or that's 0, when m is 4. So now I can write down the general solution. Y general is C1 x2 m1 plus C2 x2 m2. That's m1, m2. I would finish this, that is simplify. We're multiplying the C1 with x to the 0, that x to the 0 is 1. C1 times 1 is C1 plus C2x to the 4th. And there is your answer. Let's try some more. Once you catch on with that shorthand technique I just taught you, life will become easier. X squared, y double prime, plus 3x, y prime, minus 4y is 0. It fits Cauchy perfectly. Ignore the x to the power and the prime. There's nothing else. For example, when you ignore the x to a power and y to some prime, what's left is this 3. Here, the 4 is left. And the plus 3 and the minus 4 will be part of this. Since that's double prime, I write down not one number, and whenever I say write down a number, the first number is always m. M, and then 1 less. Plus 3, since it's the first derivative, just write down one number, that is m. Minus 4, and since the derivative is understood to be 0, write down 0 numbers. And this is 0. Now we can solve this. We have m squared minus m plus 3m. You take away m, you add 3, you're at plus 2m. Minus 4 is equal to 0. M, so this is A, B, and C in the quadratic equation. So m is negative b plus or minus the square root of b squared, which is 4, minus 4 times a times c, which is 4. That's not true. C is right there, and it is negative 4. So this is minus 16, negative 16. 4 minus a negative 16 is 20. Becomes 4 plus 16. And the square root of 20, the largest number I know the square root of that goes into 20. And I know the square root of 2 squared and 3 squared. I know the square root of 4 squared. I know the square roots of each of those numbers. Square root of 4 is 2. The square root of 9 is 3. And 5 squared, I know the square root of 5 squared. That is, I know the square root of 25 is 5. So that's more than 20. Of these numbers, what's the largest number that goes into 20? The answer is 4. So this is the square root of 4, which personally I write that way. The square root of 4 times the square root of 5. So this is 2 square root of 5. And it gets divided by 2 times 8. 2 times 1 is 2. So we have negative 2 plus or minus 2 radical 5 over 2. And we do 2 quick divisions. This division is negative 1 plus or minus. And that division, the 2's cancel. And you just get square root of 5. So we have our answer. Remember, this here, this value, this m, this here is 2 numbers. A lot of students say, of course it's 2 numbers. It's negative 1 and square root of 5. No. I mean, just like this is one number. This is one number. It's the number 9. For what we have for m is 2 numbers. One number is negative 1 plus the square root of 5. The other number is negative 1 minus the square root of 5. So we take a linear combination of our results. Remember, x to the n is a solution. And we just found out what m is. So y general is a multiple of x2, the first answer, plus c2 times x2, our second answer. There is our general solution to that problem. Okay, let's try another one. Suppose you have 4x squared y double prime plus 4x y prime minus y is 0. Let's remember there's a 1 here. Now this is in standard form, the Cauchy Euler Equation. So with respect to the first term, we kind of ignore this. That is, we write down 4. And since that's second derivative, we write down 2 numbers, m and the number before. Plus, says plus this. And we circle the x to a power times the y to a prime. And we just have 4 left. And since the prime is 1, just write down one number, minus 1. Now, if you want to work this out, that's fine. If we say that y is x to the m, then y prime will have one number in front. And just bring down the m. And y double prime, well, you bring that in front, the number in front stays. When you take the derivative of 3x to the 7, you multiply the 7 by the 3. And then make the power 1 less. Well, that's all I'm doing. I'm multiplying the m with the m minus 1. And then you get a power 1 less, m minus 2. Now, if you multiply, I'm getting what my next few comments from here, here, and here. When you multiply y double prime by 4x squared. If I multiply by 4x squared, I will get 4, that 4, times m minus 1, times this times that is x to the m, plus 4x y prime. If I multiply by 4x, if I multiply by 4x, well, I'll get 4m, and x times x to the n minus 1 is x to the m. Notice how long this is taking. And then I take away y. I take away y, which is x to the m. It says it right there. Now, take away 1 times x to the m. Now, every term has an x to the m in it. That is precisely what made it a Cauchy Euler equation. I can factor out what's in blue, and what's in red just goes in the brackets. 4m brackets m minus 1, close the bracket, plus 4m minus 1. And just like always, it equals 0. Because it started off equaling 0. So this times that is 0. That means this is 0. So look, that's exactly what I had 2 minutes ago. Learn how to do it this way. Keep practicing and it'll go much quicker. Okay, so we want to know when this equals 0. So you have 4m times m, that's 4m squared, minus 4m times 1 is easy, it's minus 4m, plus 4m, take away 1 is 0. Okay, you have 4m and you take away 4m, you have 0. If you prefer, if you take away 4m and then you add the 4m back, the 2 is 0. Cancel that. So you just have 4m squared minus 1 is 0. I don't care what that looks like in the circle. It must be 1. Because 1 minus 1 is 0. Don't care what you're calling the number. I don't care what you are calling 1. In this case, we're calling we're calling 1 4m squared. 4m squared represents 1. No matter what I put in that circle, it's 1. And of course, if in that circle I put 3, if 3 was in here instead, then something's wrong. It's not 0. 3 minus 1 is not 0. But since it's an unknown, this has to be 1. 4 times a quarter is 1. Okay. Or just divide by 4, you get m squared is a quarter. So m is, if m squared is that number, then m must be plus or minus the square root of that number. Now there's my plus minus. I actually know the square root of a quarter. It's a half. And even if you don't know the square root of a quarter, you should realize that you can break it up. The square root of the top divided by the square root of the bottom number. Square root of the 1 over the square root of 4. I know the square root of 1 and I know the square root of 4. Oh, I just learned something today. The square root of a quarter is a half. Okay, so now that I have those numbers, I'm ready to write down the general equation. It's going to be C1 x to the plus a half plus C2 x to the negative a half. Remember, our solution was x to the m. And since these differential equations are always linear, you can factor out a constant. You can have cx to the m. It will always factor out. Because when you take the second derivative of this, you're going to have c as a factor. When you take the first derivative of y, c is going to be a factor here. And when you just have y, c is going to be a factor. The c is going to factor out. That's why you can have any multiple. And there's your answer. 1, 2, 3. Try this one. This one's not going to be homogeneous. Suppose you have this problem. It equals x squared minus x. So let's get the homogeneous solution. It's going to be 2x squared y double prime plus 5xy prime plus y is equal to 0. Now, both of these equations, including the top one, are Cauchy Euler. All it has to match is the power of x and the derivative number. Power of x is understood to be 1, first derivative. The power of x here is 0, and we are taking the 0th derivative. So they match. And the right-hand side is just a pure function of x. This is Cauchy. Okay. Let's find the solution to this homogeneous. Since the second equation is Cauchy, Cauchy Euler, what we can say is 2 x squared y double prime. You can even say, since that's 2, or that's 2, I'm going to write down two numbers, m, and then the number right below it, plus 5, and that's Euler. Since the prime is 1, or the power of x is 1, just write down one number. Plus, always write down the 1 if need be. And then, since the derivative is 0, don't write down 0 numbers. And this is equal to 0. So 2m squared minus 2m plus 5m. If you prefer, and I would, instead of minus 2m plus 5m, I would do 5n minus 2m. And that gives me 3m plus 1. This is 0. Okay. Now, I looked at these coefficients 2, 3, and 1, and I think if there's a way to get 0. And I know that 2 plus 1 is 3, and if you take away 3, you'll get 1. I want this to be minus 3. Well, if I let m be negative 1, this will be minus 3, and here this will still be plus 2. Negative 1 squared is 1 times 2 is 2. If m is negative 1, this will be minus 3, and that's plus 1. So I know m equals negative 1 is a root. So I put negative 1 here, and I go 2m squared plus 3m plus 1. I always like to put a 0 here. And you add 2 plus 0, and you multiply, you put the answer there. You add these numbers, you multiply by the negative 1, and you put the answer there. And if you get 0, then you know that negative 1 is a root. But we already knew that. So when it comes to factoring this, we know that m minus a negative 1 is 0. M minus a negative 1 is the same as m plus 1. And then, since this was a quadratic, I know the numbers down here are linear. That is, it's 2m plus 1. So m is equal to negative 1, and m is negative a half. Now, you can say, oh, this wasn't bad. So y general is c1 x to the negative 1 plus c2 x to the negative 2. The answer is no. Absolutely no. That was for this solution. That was for that solution. What we found is y homogeneous. Okay. I'm going to erase most of this except the beginning problem and our homogeneous solution. Oops. Y homogeneous is c1x to the negative 1 plus c2x to the negative half. Now, in the previous sections, we learned how to solve these type problems where we had constant coefficients. You know, we say that y or particular is going to be u1 y1 plus u2 y2, where that's y1 and that's y2. I should leave you right, and u1 is going to be the division of two determinants. Same deal with the u sub 2. Should leave you here, but I'll work this one out. The first thing, and this is very important, to use the system that we used before to solve these, it has to start, the equation has to start off with y double prime, or y triple prime. That is the coefficient of the leading y to some number must be 1. That is, we have to divide by 2x squared. We divide by 2x squared. We divide by 2x squared. And then we get y double prime because of that cancellation plus 5y prime over 2x plus y over 2x squared. This is 1/2 minus 1 over 2x. Now, if I multiply the top by x, I'll get x, and I have to multiply the bottom by x. So now I just have a common denominator. It's x minus 1 over 2x. In subtraction, as you know, if the denominators are the same, just keep it and subtract the tops. Now, just to write this a little bit neater, this is y double prime plus 5 over 2x y prime plus 1 over 2x squared y, and this is that. Okay, so we have y1 and we have our g of x. And y2. We have y1, y2, and we now know g of x. It's x minus 1 over 2x. Now we can find, so the reason we divided is because g of x is not x squared minus x. Okay, it's x squared minus x over 2x squared, which reduced to this. Okay, so now we can go and try to find out where u1 prime is. u1 prime, well, the bottom one, the determinant, is going to have y1 and its derivative, and it's going to have y2 and its derivative. The numerator, since we're doing u1, is going to be 0 and then g of x minus 1 over 2x. And then y sub 2 and y sub 2 prime. That product is 0 minus this product. you have x minus 1 over 2x times x to the negative a half, which is the same as 1 over x to the half. So I'm going to write it's x over 1 over 2x, and I add the 1 and the half, and I get 3 halves. So it's negative x minus 1 over 2x to the 3 halves, divided by a couple of products. That product is going to be negative a half times x to the negative 1 times x to the negative 3 halves. Since we're multiplying, the bases are the same, we keep the base and we add. When you add two negative numbers, it's going to be negative, and you just add the two numbers. And we think of 1 as 2 over 2. So when you add those two numbers, you get negative 5 halves. Minus this product, which will be negative x to the negative 2 times x to the negative a half, which is negative, and you add the powers, it's going to be negative 2 and a half. You take away 2, and you take away a half, you take away 2 and a half. So 2 and a half is 5 halves. So we're taking away that, and since that's negative, it becomes plus x to the negative 5 halves. Okay. Little bit more arithmetic. We are adding x to the negative fifth. Here we're taking away a half, and here we're adding 1. So we're going to have a half x to the negative fifth. Okay, so let me do that division in front of us. I'll write down precisely what division I mean, and we'll move on. U1 prime is this on top, negative x minus 1 over 2x to the 3 halves, divided by this. Now, this is the same as 1 over 2x to the positive 5 halves. 1 over 2x to the positive 5 halves. But instead of dividing by that, I can multiply by the reciprocal, which is 2x to the 5 halves. Say over 1 if you like. Well, it's negative. That negative. The 2's are going to cancel. Don't worry about dividing by 1. The x minus 1 factor is going to stay. And this power minus that power. 2 and a half minus 1 and a half is 1. 1. So that's U1 prime. It's negative x squared minus x, which happens to be x minus x squared. That is what U1 prime is. If I integrate, I get U1 is x squared over 2 minus x cubed over 3. So now we have U1. Let's hope I don't go and erase it. Now let's go and redo this determinant stuff all over again. So we will find u sub 2. Or u sub 2 prime. Well, the top one is going to be y1, and then its derivative. And for y2, for the second column, since that's a 2, we put 0 and then g of x minus 1 over 2x. And in the bottom, we put y1, its derivative, we put y2, and its derivative. You should have remembered what that bottom determinant was. We have that product. Now, instead of x to the negative 1, I'm going to say 1 over x times x minus 1 over 2x. I surely know what 1 times that is. It's that over 2x squared. X minus 1 over 2x squared. Divided by I think it was 1 over 2x to the 5 halves. Okay. So what we have is x minus 1 over 2x squared times the reciprocal of this, which is 2x to the 5 halves. The 2's cancel, and we have the x minus 1, and x to the 2½ divided by x to the 2. Well, since 2½ minus 2 is a half, we get that. Distributing, we get x to the 3 halves minus x to the half. Well, that's what u2 prime is. Now luck out, because u2 is going to be right over u1. I integrate the right hand side. The integral of x to the 3 halves is x to the 5 halves divided by 5 over 2 minus x. You add 1 to that power, you get 3 halves, then you divide by 3 over 2. And now we have y2. Sorry, u sub 2. Now we can write down the solution. So just the first small part of this problem was new for this in this section. But what we've been doing now is the previous section. So it turns out that y particular is u1 y1 plus u2 y2. Well, u1 is x squared over 2 minus x cubed over 3 times y1. So y1 is x to the negative 1. I'm going to write that as 1 over x. Plus u sub 2, which is 2x to the 5 halves over 5 minus 2x to the 3 halves over 3 times y2, which is x to the negative a half, or 1 over x to the half. Okay, just clean this up a little bit. This times that is going to be x over 2 minus x squared over 3 plus 5 halves, 2½ minus a half is just 2. So it's going to be 2x squared over 5 minus 1½ minus a half is 1. So it'll be minus 2x to the 1 over 3. That answer is y particular. That is y particular. If you want y general, not actually going to do it, but write that down again and then add the homogeneous, which is in the top right corner. It's c1x to the negative 1 plus c2x to the negative a half. And that long problem is now finished. Okay, try another one, please. Suppose you have x squared y double prime plus xy prime plus 1 is 0. Now this one's going to be different because the quadratic equation we're going to get is going to give us complex roots. Since it is in Cauchy Euler form, those match, the understood number by the x and the prime matches, everything matches, and this should be plus y, excuse me. So we're going to have two numbers, m times n minus 2, plus just one number, plus the understood 1. There's all understood 1's in front. And this is equal to 0. So you have n squared minus 2m plus 1m, that's minus m, plus 1 equal to 0. Strike the 1. That's A, that's B, and that's C. So m is equal to negative b, which will be plus 1, plus or minus b squared minus 4 times a times c, all over 2 times 1, which is 2. So you get 1 plus or minus, that's 1, and that's 4. 1 minus 4 is negative 3 over 2. Okay, so of course I have an error here, sorry. Of course I have an error. So it's when I write down two numbers, it should be m and then m minus 1. I guess I said two numbers, so I wrote down 2. So let's write this down again. M times m is m squared minus m plus m will cancel plus 1. So that must be negative 1. M squared must be negative 1. So m is the square root of negative 1 or plus or minus. If m squared equals anything, then m is always plus or minus the square root of the anything. And that what I just circled is I. Does that mean this equals I? No, because there's other stuff. Just what I circled is equal to I. But we do have plus and minus in front of it. And to plus I, you can add 0. It won't affect it. And to negative I, you can put 0 in front. And like earlier, when we had the e to the alpha x's, this is a, and this is the same as 1i. I is the same as 1i. So that's a, and that's b. And the solution to these Cauchy Euler equations, when you get complex conjugate roots, is y is equal to x to the a, just like before, and then you get c1 cosine of b, which also dx normally, but now is b ln x, plus c2 the sine of b ln x. Now since our a is 0, x to the 0 is 1. And 1 times this mess is just that mess. So y general is going to be c1 cosine of b. b is 1. So you get 1 times ln of x, which is just ln of x, plus c2 times the sine of 1 ln of x. And there is the answer. When you have complex roots, that's the form. When you have a repeated root that repeats twice, you have that y is equal to c1x to the m plus c2x to the m ln of x. That's if you have a repeated root. When you have complex roots, you get this form. And you can take the derivative and make sure this stuff is right and all that, and you'll prove it and you'll be all happy. But that's not enough. You have to remember this form for the test, unless it's going to be given to you. You have to memorize this. Okay, let's try at least one more. Suppose you have x squared y double prime plus xy prime plus 4y is 0. This is surely Cauchy. So, there's no number in front. I care. There's a number in front. There's no number in front. If there were, I would write it down. Since it's x squared or y double prime, we write down two numbers, m minus 1, plus, there's no constant in front, I just write down one number, plus 4, I wrote down one number here because it was one derivative. It's y prime, not y triple prime. And here, the powers, the derivative is understood to be 0. So I don't write down any numbers. Equals 0. So I have m squared, and I take away m, but then I add back m. That cancels. Don't forget to now add on 4. And we get 0. So that must be negative 4. Negative 4 plus 4 is 0. So m squared is negative 4. So m is plus or minus the square root of that number. The square root of that number is 2i. So m is really 0 plus or minus 2i. Okay, so that's A and that's B. We're done. Y general is going to be x to the A, that is x to the 0, which is 1, times what's in this bracket. So it's just what's in the bracket. It's going to be C1 cosine of B ln x plus C2 times the sine of B times ln of x. There's the answer. Okay, let's try one more problem. Let's make sure that the complex number has a real part. For example, 7 minus 4i, that's the real part, that's the complex part. Or imaginary part. Sorry, imaginary part. That's the real, that's the imaginary, and the whole number is called the complex number. X squared y double prime plus 3x y prime plus 5y is 0. This Cauchy, there's no coefficient in front, so I just write down two numbers, m minus 1, plus, here, because it says plus, there's a number in front, and since it's x1, x to the 1, y single prime, I write down one number, plus, I write down 5, and this is 0. So you have m squared, take away m, but then add 3. That's plus 2. Plus the 5 is 0. That's A, B, and C. So m is negative b plus or minus the square root of b squared, which is 4, minus 4 times A times C. This is 4, and that's 20. 4 minus 20 is negative 16. And this is all over 2 times 1. I won't bother multiplying by 1. So I get negative 2 plus or minus, well, the square root of negative 16. Well, negative 16 is 16 times negative 1. Since not both numbers are negative, I can separate it into the square root of one number times the square root of the other number. I know the square root of 4, and I also know the square root of negative 1. It's I. So 4i all over 2. Well, that division is negative 1 plus or minus. That division is 2i. So A is negative 1 and B is 2. Piece of cake. Y general is x to the A times C1 cosine of B ln of x plus C2 times the sine of B ln of x. And there's your general solution to the top equation. And this completes the section on the Cauchy Euler differential equations.